Hello students, I am Professor Varang HD from Govindanikam Junior College of Science, Arts and Commerce, Saurabh. Graphical representation of simple harmonic motion. There are two cases of oscillations. Graphical representation can be obtained for two cases. First case is when oscillation starts from mean position along positive x direction. Along positive x direction. So we have to represent graphically when oscillation starts from mean position. We have studied two expressions for displacement when particle starts from mean position and when particle starts from extreme position. So our first case is when oscillation of the particle starts from mean position. So we have that expression for displacement. The displacement in this case is given by x is equal to a sine omega t. This is the expression for displacement of a particle when oscillation starts from the mean position. So by using this expression we can find out what is the velocity of the particle, what is the acceleration of the particle by simple way of taking derivative of displacement with respect to time. So velocity phi is the derivative dx by dt with respect to time. Derivative of x with respect to time. So derivative of RHS is a as a constant term, a as it is. Derivative of sin omega t is cos omega t. Derivative of omega t with respect to time is omega. Therefore a omega cos omega t is the expression for the velocity of the particle. So we have these two relations. Again we can find out the acceleration. We denote by the letter A. So acceleration we denote by symbol A is equal to rate of change of velocity dv by dt. So we take derivative of this velocity. So a omega as it is, derivative of cos omega t is minus sin omega t, therefore we introduce a negative sign. So minus a omega, and cos derivative of cos omega t is sin omega t, and derivative of omega is omega, therefore omega multiplied by omega is omega square sin omega t. So these are three expressions for displacement x, velocity phi, and acceleration a. And from these expressions we are going to find out graphical, how it can be expressed graphically by forming a table for displacement, velocity, and acceleration with respect to angle theta. So theta, or we can call it as here omega t. In this case we have to make the table. That is, let us consider the time t is taken as the first variable, t having different values taken along the x-axis. So t is equal to 0 is the first value. So t is equal to half t by 4, t by 4 quarter value. Then t by 0 t by 4, 2 t by 4 is t by 2, then 3 t by 4, and 4 t by 4 is t, complete time period t. So these are the values of time t. So we make a table, and for these values, what is the values of theta and what is the value of x phi and acceleration A. So first we take, this is the vertical columns we make in this table by simple way. Yes, this much. Now we are going to have the value of theta. So theta is equal to 0. Then this is the first value, theta is equal to 0. Then pi by 2 value, pi by 2 value, 2 pi by 2 is, 2 pi by 2 is pi. Then 3 pi by 2, 0 pi by 2, 2 pi by 2, 3 pi by 2, and 4 pi by 2 is 2 pi. These are the values of theta. Then we take the value of variable x here. The values of x can be obtained by using the relations. Then values of phi, velocity, and then acceleration A. So displacement x can be obtained by putting the value here. Sin 0 is 0. So the value of x will become equal to 0. Sin pi by 2 is 1. Then x will be equal to amplitude A. Then sin pi is again 0. Sin pi is again 0. Value becomes 0. 3 pi by 2, sin 3 pi by 2 is minus value, minus A. Again sin 2 pi is 0. This is the displacement value. By putting the values of omega t or theta, we can have these values of x. And velocity expression, by using this velocity expression, we will have the values of velocity when 0, and that is theta is equal to 0, cos of 0 is 1. So it is value having A omega. A omega is the value. Then cos of pi by 2 is 0. Therefore total value becomes 0. Cos of pi is minus 1. Therefore it is minus A omega. Then cos of 3 pi by 2 is 0. The value becomes 0, and cos of 2 pi is again plus 1, therefore its value comes out to be A omega. Now for acceleration, we put the values again. Sin 0, for the value of theta is equal to 0, sin omega t is theta, and that is 0. The value of acceleration will be equal to 0. Then for pi by 2, sin pi by 2 is 1, so it will be minus A omega square, minus A omega square, value of minus A omega square. Then sin pi is again 0, value becomes 0. Then plus A omega square, as you can easily get, and again 0. This table is filled by putting the values of omega t, that means theta, by using this table. The corresponding values of times are shown in the top row of this table. By using this table, we can plot the graph. We can put the values and we can plot the graph of displacement, velocity and acceleration. We represent displacement along this x-axis. Similarly, velocity, graph of velocity is obtained here, and graph of acceleration A is obtained here. So we can draw the graph. When values we are putting, theta is equal to 0, what is the x is equal to? So values of angles we are going to put here. 0, starting angle is 0, then pi by 2. By equal distance we could keep the values. Pi by 2, then pi by equal distance, pi value, then 3 pi by 2, 3 pi by 2, and 2 pi. 2 pi. Similarly are the cases here. We are not going to write the values again because already we have written in the first graph. Same positions are taken for the values of omega t, and we can plot the graph by putting the values. Theta is equal to 0, x is equal to 0, so we get the first point. Let us consider the maximum value of amplitude. We can show here by drawing this graph having some length like this. So maximum value here is a or plus a. So here plus a is taken on the top side, plus a for amplitude. Minus is taken on the bottom side as negative value of displacement. Now when theta is equal to 0, x is equal to 0, graph starts from here. When theta is equal to pi by 2, x is equal to a, point comes here. Theta is equal to pi, value comes out to be 0, this value. Again for 3 pi by 2 it is minus a, bottom value, maximum, bottom value, let us notify this point. And for 2 pi again it is 0. So continue the graph. So graph nature will be like this. Like this. Graph will go further like here we have 2 pi, therefore we have not completed that part of the graph. Then for velocity, when theta is equal to 0, velocity is a omega. So we represent a omega plus on the upper side, plus value, plus a omega on the bottom side, minus a omega. So it is starting from plus a omega. The point will be here. Then it is 0 for pi by 2. It is 0. Then it is minus a omega, negative value. We point here as this. Then again 0 here. And then plus a omega t is here. So we continue the graph. The nature of the graph will be like this. And for the third case, acceleration, we have 0 for theta is equal to 0, it is starting from 0. And minus a omega square is a minus value we are putting here, minus a omega square, and here is plus a omega square. We write here plus a omega square. So starting from 0, then for pi by 2 it is negative. Therefore, point comes out to be here. Then 0, point comes out to be here. Then plus a omega square, it is maximum value positive here, and again 0. Like this. We draw the curve to these points. The nature of the graph is like this. We can be continued further like this. So these are the graphical representations of displacement, velocity and acceleration by using the table and the expressions for displacement, velocity and acceleration of a particle performing linear simple harmonic motion when particle starts from mean position. Let us stop here. Thank you.